So here we are at Chapter 7, Chemical Reactions and Quantities. So in Chapter 6, we looked at compounds and how atoms make compounds. And here we're going to look at how compounds combine and recombine to make new compounds. So a chemical reaction always involves making something new. Making something new. And we express our chemical reactions as equations. And our equations will have a reactant that enters into the reaction and it has product that is made. Our chemical equation is also going to show us the relative amounts of these things. The reactants are shown on the left side and the products are on the right. So we'll have reactants, an arrow, and then the products. Our chemical equations need to be balanced, and that means we have the same number and type of each atom on in the reactants as in the products. So what we don't want to have happen is to have atoms appear or disappear as a reaction occurs. Whatever is in the reactant side also needs to be in the product side. And this is the conservation of matter. Things don't appear and disappear. So there are 4 steps to balancing our equation. First, we want to make sure that we have the correct formulas for the reactants and the products. Then we need to count the atoms of each element. So, for example, if I have 2 water molecules, that's going to give me 4 hydrogens and 2 oxygens. Atoms. I have a 2 in the front, so 2 times the 2, that small subscript means I've got 2 hydrogens, so 2 times the 2 gives me 4 hydrogens, and 2 times the 1 oxygen gives me 2 oxygens. This one's a little more complicated. Here we'll have 2 calciums, whatever's in brackets needs to be multiplied by 2. So we'll have 2 times 2 nitrogens for 4 nitrogens. And then we've got oxygen, we've got 3 oxygens times 2 for 6 oxygens times another 2 for 12 oxygen atoms. When we go to balance the equation, we'll be changing the coefficient. Coefficient is the large number in front. You may not change any of the subscripts. We'll be doing some examples so you'll get to see. Don't change any of the subscripts. Those are the little numbers, like the 3 and the 2 here. And then at the end, you always want to go through and check your work to make sure that you haven't made any mistakes. When we balance equations, we need to remember that there are 7 diatomic elements. These are not hard to figure out. There's 7 of them. We start with atomic number 7, that's nitrogen, and we make the number 7. Well, that's 1, 2, 3, 4, 5, 6 elements, so we have 1 left over, and it'll be atomic number 1, hydrogen. So if we have a hydrogen gas given off, the hydrogen is going to appear as 2 hydrogens stuck together. Nitrogen is the same way. Oxygen, chlorine, bromine, and iodine. Those will all appear as diatomic. So let's balance our first equation. We can start with any element we want to start with. It's always good to start with something that only appears in one place on each side. So we'll start with the nitrogen. We have a nitrogen here and a nitrogen over here. So on the reactant side, I have 1 nitrogen. On the product side, I've got that subscript. That means I've got 2 nitrogens. So the way we change the number of nitrogens is by changing the coefficient, which is the number in front. If I change that to a 2, now I've got 2 nitrogens in the reactant side and 2 nitrogens in the product side. So let's look at the oxygen next. On this side, I've got 2 oxygens because I've got a 2 in front of this nitrous monoxide. Over here, I have 1 oxygen because I have just 1 water molecule. I can change that though. I can change the coefficient to a 2, and now I've got 2 waters and 2 oxygens. I'm going to put, just so that doesn't look like a 0. Okay, our third atom that we need to look at is hydrogen. Over here we've got 2 hydrogens, and over here we've got 2 times 2, so that's 4 hydrogens. We can change the coefficient in front of the hydrogen to be 2, and now I've got 4 hydrogens on that side as well. Now we can double check that we still have 2 nitrogens, 2 oxygens, and 4 hydrogens on the reactant side, 2 nitrogens, 2 oxygens, and 4 hydrogens on the product side. And so we are balanced. So let's look at this one. Let's start with aluminum. We have 1 aluminum on this side and 2 aluminums on the product side. So we're going to need to change the coefficient here to make it a 2. Now I have 2 and 2 for the aluminum. If we look at the iron, we have 1 iron on this side and 1 iron on this side, so that looks good. Now let's look at the oxygen. We've got 1 oxygen over here, and we've got 3 oxygens over here. So that doesn't balance. I'm going to need to add to oxygens over here. I can do that by doing taking a coefficient there. So I have 3 oxygens on each side. But wait, when I added the 3, I also made it 3 irons. And I'm going to need to put a coefficient here to give myself 3 irons on that side as well. Now let's do this last one. This one's a little bit tricky. I'm going to start with the oxygen, partly because I'm looking and I've got 3 oxygens over here on the reactant side, and I have 2 oxygens over here on the reactant side. Well, the only way I'm going to be able to balance this, I have to have the same number of oxygens on the reactant side as I have on the product side. The way to balance that is going to be to have 6 oxygens. If I multiply this one by 2 and this one by 3, I'll have 6 oxygens on each side. So that's a little trick. Once I've done that, I can balance the iron. I've got 4 irons on the product side, 2 times 2. I have 1 iron over here on the reactant side, but I can add a 4 in the front of that, and now that's balanced. Now let's finally look at the carbon. We have 1 carbon on the product side and 3 carbons on the reactant side, 3 times 1. So we can change the coefficient here and get 3. I want to do one more just to show you that if you have a polyatomic ion, we've got sulfate here, and we've got the polyatomic ion here, and we've got it there. It's much easier to balance if we keep that together. Polyatomic ion can fall apart, but you'll save time by assuming that it's going to stay together. So on this side we have 1 sulfate, 1 SO4. Over here we've got 3 SO4s. So we can balance our sulfates. 3 sulfates. Do the coefficient, change the coefficient in the front, and now we've got 3. Here we've got 2 aluminums. Here we have 1 aluminum, but we can add a coefficient here and give ourselves 2 aluminums. And then lastly, we need to look at the hydrogens. Here we've got 3 times 2, so that's 6 hydrogens. Over here we've only got 2 hydrogens, but if we put a coefficient in front of it, we can have 6. Notice I don't ever change any of the small numbers, the subscripts. To balance an equation, you only change the big numbers in the front.